Hi guys! So before we can get to anything very interesting or mathy or calculus-y in section 3.4, we need a little bit of vocabulary, we need a little bit of basics, all right? So if you'll take a look at these first two curves on this sheet, I'm going to call them curve 1 and curve 2, all right? We recognize that each of these curves, both of these curves, are increasing, and yet they are different, right? We acknowledge that there's something fundamentally different about the way in which they increase. And if we were in class, I would probably ask you to brainstorm or spitball some ideas about what is different about the way they increase. But in this case, I'll just invite you to take a quick look, right? Curve number 1 looks like it starts out growing kind of slowly and then ramps up, right? It grows faster and faster, right? Whereas curve 2 starts out increasing pretty fast, right? We shoot up pretty quickly, and then things sort of seem to taper off, right? It's still increasing, it's just not doing it by as much. So I would say that curve 1 increases at an increasing rate. And in fact, I want to be very clear here. I am going to write that curve 1 is increasing, and that curve 2 is also increasing, right? But curve 2 is increasing at a decreasing rate. It's sort of sputtering out, slowing down. All right. Now I direct your attention to curves, what I'm going to call 3 and 4. Right? Each of these curves is decreasing, right? In fact, curve 3 is decreasing, right? And curve 4 is decreasing as well, but there is something sort of fundamentally different about the way that they decrease. All right, so I'm going to label curves 3 and 4 as both decreasing. And we give a name to this, all right? We have a word for this, the way in which curves 1 and 2 differ from each other, and the way that curves 3 and 4 differ from each other, all right? We would say that curve 1 is increasing and concave up, all right? You may have heard the term, concave up, concave down, or convex. Here we will strictly use concave up or concave down, all right? But curve 1 is increasing and concave up. Whereas this curve here, number 2, is also increasing, but it is concave down. Okay, and it's sort of like, which way does the curve bend? All right, and now I would like to introduce you to what I call the Tess-Fleming method for determining concavity. She came up with it. It is hers and her own. So I like to think of concave up and concave down as either the curve is part of a smile or part of a frown. So in the case of the first curve, right, does this curve look like it's smiling or frowning? And now this is the Tess-Fleming method right here. Put eyes over it. Yeah, that curve is smiling, so it's concave up. Curve number 2, all right, if we apply the Tess-Fleming method and put eyes over it, it's frowning, so it's concave down. This is legitimate. All right, so now let's take a look at curves 3 and 4. All right, and I'm going to go ahead I am going to put eyes over both of them, and it would appear that curve 3 is concave up because it's smiling at you, and curve 4 is concave down because it is frowning. So we would say that curve 3 is decreasing, yet still concave up. And curve 4 is decreasing, but it is concave down. So now, what I would like you to do next is when I say go, all right, you're going to pause the video. And what I would like you to do is on each curve, mark 3 distinct points on each curve. And then, at each of the points that you've drawn, draw the line tangent to the curve. Okay, so 3 distinct points on each curve, draw the tangent line there. Go. Okay, so I drew my tangent lines. I sincerely hope that you fared better than I, because these are pretty terrible, but they'll get the idea across. All right, and now the question I'm going to ask you, for the tangent lines that you drew, let's take a look at the curves 1 and 3, right? Both of them are concave up, all right? And in both cases, where do the tangent lines sit relative to the curve? Hopefully you notice that all of the tangent lines lie below the curve. All right, so if you're not sure, if you've tried the Tess-Fleming method and put eyes over the curve and you're not sure if it's concave up or concave down, pick a point, draw a really good tangent line. If the tangent line is below the curve, it must be concave up. All right, and similarly, for curves that are concave down, such as 2 and 4, all of the tangent lines that you draw should sit above the curve. So if your curve is concave down, all of your tangent lines are above it. And so that's exactly what we're going to fill in this little, oh, nope, there's nothing to fill in. It's already spelled out right there for you, right? A curve is concave up over an interval if its tangent lines lie below the curve, or a curve is concave down if its tangent lines lie above the curve on that interval. So hopefully you have a sort of decent idea about what is concave up and what is concave down. All right, let's move on to the next page. Okay, so now here is a graph, all right, a curve now that looks like it does a number of things. It switches from increasing to decreasing. It changes from concave up to concave down and vice versa because I see that I'm looking at smiles and frowns. So let's try to identify a few things about this curve, and we're going to round to the nearest half if we need to. All right, so number 1 asks us to identify any local extrema. So by local extrema, I'm talking about turning points. And I see that I have one here, here, and here. Okay, about. All right, so we'll say that we have local extrema at x equal to, let's see, -2, 4, 6, 8, -8. If that's wrong, that's what I'm calling it. All right, at x equal to -1, and also at x equal to 2, 4, 6.5, we'll call that. Okay, so that's our local extrema. All right. Number 2 asks us over which intervals is the function increasing. All right, not a trick question, just where is the function increasing? All right, and that's going to happen between our first 2 local extrema. So we'll say from -8 to -1, but then also from 6.5 onward. Okay. And then part 3 asks us over which intervals is the function decreasing. Well, that will be everything up until -8, and then the section of the curve between -1 and +6.5. So let's write that down. So we have from -infinity up until -8, as well as from -1 through 6.5. And we feel like these two sets, right, these two sets of intervals should be complementary, right? If we put them together, we would get the whole curve. Okay, now, All right, just as it is often helpful to identify intervals of increase and decrease by first finding your turning points, it is helpful to identify intervals of concave up versus concave down by first finding what we call inflection points. So just like how a turning point is where the curve switches from increasing to decreasing or vice versa, an inflection point is where the curve switches from concave up to concave down or vice versa. This is going to take some practice. I'll take you through one. Don't worry if you don't get it, first time around. Okay, so I'm going to look at my curve. I'm going to zoom in a little bit just to make it a little easier. It takes a trained eye to be good at this. But I noticed that so I'm going to start on the left-hand side. When I start out, it would appear that it's smiling. It's a little bit of a derpy smile, but whatever. All right, I don't judge. Okay, and it looks like it's a smile for a little while. But now, okay, by the time I get to like up here, it's frowning, right? So if I started out smiling and I ended up frowning, at some point I had to switch. And so our goal is to identify where did we make the switch. Alrighty, so in this case, I'm just gonna kind of give it to you. All right, I would say, and with a certain acceptable margin of error here, the inflection point is at about x equal to -5, right? Up through 5, things look pretty smiley. And then once we hit -5, things look kind of frowny. All right. And so now we continue, right? We're a frowny face up through, x equal to -1. Okay, on the other side, we're still kind of frowning. All right. And yet, by the time we get to our other turning point, we're smiling. So somewhere in between, we had to switch. Let's try and figure out where. I would probably, if I had to pick, I would say about here. Again, with a certain margin of error, because this is sort of tough to pick out. All right, so I would say that x equal to 3 is another inflection point, right? It looks like to the left of 3, we're still kind of frowning, and to the right of 3, we're basically smiling. So I would say x equal to 3 is a good approximation. And then we're concave up for the rest of the time. All right, so we have two inflection points, x equal to -5 and x equal to +3. So let's add those in. Notice that your inflection points do not coincide with your turning points. In fact, they should not. All right, so number 5 asks us over which intervals is the function concave up. All right, so we're basically looking for all of those intervals over which we're smiling. So I would say that we are concave up all along this section of the curve, right? And then this section of the curve, right? So that'll be from -∞ to -5, and then from 3 onward. And then if I were to consider those intervals over which the function is concave down, right, well, again, that should sort of be complementary to the set of concave up, right? That's this big old frown right in the middle here. Okay, so that would be from -5 to +3. All right, so now, all right, hopefully you have a sort of general sense of what it means for a function to be concave up or concave down. This is all I want to do up until our class time tomorrow. So please come ready with questions. Hasta mañana.